Hello students, in this video we are going to solve the JEE mains questions related to the chapter communication system. So we'll start with the first question over here. So in the first question, what is given? An antenna is mounted on a 400-meter tall building. So in this numerical, the data is given that the building is 400-meter tall. Capital H is height of the building. Okay. What will be the wavelength of the signal that can be radiated effectively? So we have to find the wavelength of the signal that can be radiated effectively by a transmission tower up to a range of, okay, so the range of transmission there, so D is given as range of transmission, range of transmission. So range of transmission given over here is 44 kilometer, or you can add 44 into 10 raised to 3 meter. By the way, radius of earth is 6400 kilometer, so we can write it as 6400 into 10 raised to 3 meter. Okay, so while solving now, first we'll see the range of transmission formula. So the range of transmission formula is given by under root 2 into height of the antenna into radius of earth. So we have to find the height of antenna. So if we take d square equals 2h radius of earth, h will be d square upon 2 into radius of earth. To d square, so 44 into 10 raised to 3 the whole square upon 2 to radius of earth is 6400 into 10 raised to 3. So from the data given we have 44 into 44 upon 2 to 6400, or we can take these two zeros with 10 raised to c, so this will be 10 raised to 5 to 10 raised to 6. So this will become 5 in gas in numerator, so minus 5. Here 2 ones are 2, 22s are, we have 4, 16s are 4, 11s are 2, 8s are 2, 11s are, so we have 121 upon 8 into 10 raised to 1. So if we divide 121 by 8, so we get 15.125 into 10, or we can add 151.25 meter. So this is the distance of the height of antenna, this is h, height of antenna. So wavelength by 4 is the height of antenna, so wavelength will be 4h. So 4 into 151.25. So if you multiply this, you will get 605 meter. So that is the wavelength that will be transmitted. So the correct option is B. I hope students you have understood this question. Correct option is B. Moving ahead with the next question, student. So we have match list 1 with list 2. Now as you can see in the list 1, there is the distance above the earth surface, so 10 kilometer above earth surface, 70 kilometer height over earth surface, 180 kilometer over earth surface, 270 kilometer over earth surface. And the list 2 we have thermosphere, mesosphere, stratosphere, troposphere. So different layers over the earth surface. So we'll see like what is the range. So from 0 to 10 kilometer above earth surface, above earth surface, above earth surface, we have the layer which is we are having troposphere, in which we live. So students, till 10 kilometer we all have that clouds, rains, right? So all these things occurs in troposphere, which is till 10 kilometers. Now if we go above 10 to 70 kilometers, students, then we get stratosphere. Stratosphere. Now even our ozone layer is in stratosphere, students. That is above 10 to, that is between 10 to 70 kilometers. Ozone layer is around 50 kilometers above the Earth's surface. Then we have from 70 to 180 kilometer we have mesosphere, students. So mesosphere is between 70 to 180, and the last layer that we have, that is above 180 to 270, we have thermosphere, in which there are ions that are forming. Okay, so in thermosphere there are the ions that are forming. Ionosphere it is also called. So if we'll see from option A, we have troposphere, that is 4. For B, we have stratosphere, that is 3. C, we have option mesosphere, that is 2. And D, we have option 1, that is thermosphere. So it is 4, 3, 2, 1. So 4, 3, 2, 1 is the first option, students. So correct option is A. I hope you have understood. Okay, students, moving ahead with the next numerical. We have two identical antennas mounted on identical towers and separated from each other by a distance of 45 kilometer. So the distance between the towers is 45 kilometer. What should nearly be the maximum height of the receiving antenna to stop the signals, to receive the signals in line of sight? Suppose one antenna is over here. So if we talk about line of sight, so this second antenna is over here. The distance between them is 45 kilometer. So if we take this distance small d, this distance as small d. Small d is under root 2hr. This is also under root 2hr. Now remember, let both the height of antenna is same because they are identical. So with this distance we take it as capital D. From here, so capital D will be equal to 2 into small d, that is 2 under root 2hr. Capital D is distance between the antennas 45 kilometer. So if we take d square, then that will be 2 square is 4, 2 is 8 hr. So height of antenna will be d square upon 8r. So d is 45 kilometers, so 45 into 10 raised to 3 meter square upon 8. Radius of earth is 6004, so 64 into 10 raised to 5 meter. We have converted into meters. So this will be 45 into 45 upon 8 into 64 into 10 to the power. So 3 to the 6, 5 become numerator, become minus 5. So this will be 5 minus 6 is 1, or 6 minus 5, sorry, 1. So if you'll solve over here, so 45 square will become 2025, and if you multiply 64 with 8, we get 512 into 10. So your H will be equal to 20,250 divided by 512. Now if I take approximately 20,050, so that will be approximately 40. If you see exact, approximately 40, if I take 50,500 into 40 will become 20,000. So height will be approximately 40 meters. So if we see the options, we have 14, near about 40 is option B, that is 39.55 meter. So the correct option is B. I hope students you have understood the question. Okay, students, so moving in the next question, we have in communication system only 1% frequency of signal of wavelength 800 nanometer can be used as bandwidth. Okay, so the signal of wavelength is 800 nanometers, so 800 into 10 to the minus 9 meter. So this is the wavelength of the signal. Okay, can be used as bandwidth. How many channels of 6 megahertz bandwidth can be broadcast by this? Okay, so we have wavelength. So we can find out its frequency. Frequency is velocity upon wavelength. So velocity is 3 into 10 raised to 8 on wavelength is, actually we can take this as 800 as 8 into 10 raised to minus 7. So 8 into 10 raised to minus 7. So that will be 3 by 8 into 10 raised to 7 and 8 is 15. So 3 by 8 is 0.375 10 raised to 15, or you can add 3.75 into 10 raised to 14 hertz. This is the total frequency of the bandwidth. Now we can only use how much? We can use only 1% of the frequency of signal wavelength can be used. So 1% of frequency will be 1 by 100 into 3.75 10 raised to 14. So that is 3.75 into 10 raised to 12 hertz. So this much frequency of the bandwidth we can use. So total number of channels for signals, that will be equal to the total bandwidth available. So total bandwidth available upon bandwidth upon bandwidth of TV signal. So total bandwidth available is 3.75 into 10 raised to 12. Bandwidth of TV signal is 6 into 10 raised to 6. So 10 raised to 6 goes in numerator, so it will be 10 raised to 6, and 3.75 divided by 6, so that will be 0.625. So you multiply 1, so this will be 6.25 into 10 raised to 5 number of channels. So if you'll see, the correct option over here is C. So correct option is C. I hope students you have understood the question. Okay students, so we'll move ahead with the next question. A transmitting antenna at top of a tower has a height of 50 meter and the height of receiving antenna is 80 meter. What is the range of communication for line of sight mode? Okay, so similar to previous some questions. So line of sight mode, so one antenna is over here and this will go, this is the line of sight mode, this is another antenna. Here the antenna height transmitting, so this is transmitting data and this is receiving. So height of transmission is 50 meter, okay, and height of receiving antenna is 80 meter. So till this distance it is D, here also it is D. So maximum for line of sight mode, D maximum will be equal to under root 2H for transmission and under root 2HR for receiving. So that will be under root 2, h is 50, r is 6400 kilometer. So 6.4 into 10 raised to 6 plus under root 2 into 80 into 6.4 into 10 raised to 6. So here 10 raised to 3, here it will 10 raised to 3, so we can take 10 raised to 3 common. We have under root of, this will be 50 to the 100, so this will be root of 640 plus this will be root of 80 into 2 is 160. 160 into 60 or 6.4 is 1024. So 10 raised to 3, we have under root of 640. Under root of 640 is 25.29, so 25.30 plus under root of 1024 is 32, so we have 57.30 into 10 raised to 3 meter, or you can write 57.3 kilometer. So correct option is D. I hope students you have understood the question. Okay students, so we'll move ahead with the next question. So in the data is given, a signal of 0.1 kilowatt is transmitted in a cable. So the power transmitted, that is output power, is 0.1 kilowatt. So that will be 0.1 into 10 raised to 3 watt or 10 raised to power 2 watt. That is the output power. The attenuation of the cable, attenuation means loss. So the attenuation of the cable is minus 5 decibels per kilometer. So your rate of attenuation, loss per kilometer. So rate of attenuation is minus 5 decibel per kilometer. So total loss will be how much? Since the cable is of 20 kilometer in length, so total loss is rate of attenuation into length. So minus 5 into 20, so that will be minus 100 decibel. That will be your total loss. Now we know the formula for gain. Gain is output power upon input power, but that is in decibels. So if you remove the decibels, so then that will be 10 log 10 output power upon input power. But the loss, we are not gaining, we are losing. So beta will be minus 100. So how much? Minus 100 is minus 10 log 10 output power upon input power. So 10 ones are 10, tens are, so you will have minus 10 log to the base 10 output power upon input power. So if we take log over here, that will be anti-log, so that will 10 to the power minus 10 output power upon input power. So output power is input power into 10 to the power minus 10. So input power is how much? We have found out, that is 10 raised to 2 watt. So 10 raised to 2 into 10 raised to minus 10. So your output power is 10 raised to minus 8 watt. So the power received at the receiver is 10 raised to power minus x. If we'll check the power, we compare, but output power given is 10 raised to minus x watt. So if we'll compare, we'll get x as 8. So the value of x is 8. I hope students you have understood this question. Thank you. Okay students, so moving ahead with the next question. For very high frequency signal broadcasting, dash kilometer square of maximum service area will be covered by an antenna tower of height 30 meter if the receiving antenna is placed at ground. So since the receiving antenna is placed at the ground, on the height of the antenna which is given, that is 30 meter, we have to find the area which is in kilometer square. So we'll convert 30 meter into kilometer. So 30 into 10 raised to minus 3 kilometer. Radius is also in kilometer, 6400 kilometer. Okay. Now, so we have to find the area. So, but what is the maximum range? That is under root 2 h into r. So, area covered will be, it will be a circular part. So, it will be pi r square. So, r is your range, so pi d square. So, pi d is 2 h r as the root of square root square will be becoming 0. So, this will become 2 pi h into r. You just have to multiply 2 into 3.14, height is 30 into 10 raised to minus 3, r is 6400. So when you multiply all these terms, you will get as approximately 1206 kilometer square. That will be a final area. I hope students you have understood this question. Okay students, so in the next question we have given a telephonic communication service is working at a carrier frequency of 10 gigahertz. Okay, so carrier frequency is given 10 gigahertz, so 10 to 10 raised to 9 hertz. Okay, only 10% of it is utilized for transmission, so we can only use 10%. Okay, so 10% of carrier frequency will be 10 upon 100 into 10 to the power 9. So 100 and 10 get cancelled. 10 to the power 9 hertz is available. Okay. So next what is given is how many telephonic channels can be transmitted simultaneously. Each channel requires a bandwidth of 5 kilohertz. Okay. So total number of channels transmitted, that will be equal to ratio of total bandwidth available total bandwidth frequency available upon the frequency of each channel, upon frequency of each channel. So total bandwidth available is 10 raised to 9 and frequency of each channel is 5 kilohertz. So 5 into 10 raised to 3. So we can write it as 10 upon 5 to 10 to the power 8 upon 10 to the power 3. So 10 upon 5 is 2 into 10 to the power 5. So 2 into 10 to the power 5. That many number of channels can be transmitted. I hope you have understood, students. Okay, students, so in the next question we'll see to double the covering range of the TV transmission tower, its height should be multiplied by. Okay, so let initial range be D. So D2 is 2D. We take initial height as H. So H2 must be how much? Now we have D as under root 2HR. So this is D1, this is H1. D2 will be under root 2 H2R. So since D is directly proportional, so D2 upon D1 is H2 upon H1 in root. So D2 is 2D1, D2 is 2D upon D under root H2 upon H. So if D and D gets cancelled, take squares, it will 4 equals H2 upon H. So H2 will be 4 times H. So it should be multiplied by 4. This was a very easy question, students. I hope you understood. In the next question, students, a radar has a power of 1 kilowatt and is operating at a frequency of 10 gigahertz. Okay, it is located on a mountain top of height 500 meter. The maximum distance up to which it can detect an object located on the surface of the earth of radius will be, okay, suppose this is the radius of curvature and this is the radius of the earth. So this will be your height h. Okay, so the maximum distance it will go will be up to somewhere around here. So this will be your maximum range, right? But this distance is again radius only. So your range, this will become, we can apply Pythagoras theorem from here. So we will get hypotenuse square, that is h plus r the whole square, equals one side square plus other side square. So range will be equal to h plus r the whole square minus r square and root. So this is a plus b the whole square. So a square plus 2hr plus h square plus, sorry, minus r square. So r square gets cancelled. So we have 2hr plus h square. Now since h is very smaller than r, so h square is neglected. So we will have range as under root 2hr. So 2, height is in 500 meter. So we can consider it as 0.5 kilometer or half kilometer. So 2 into half into 6,400 kilometers. So 2 and 2 gets cancelled. So that will be 80 kilometer. The correct option is 80 kilometer. I hope you have understood this, students. Okay, students, so we'll move ahead with the next question. Now here the modulation questions are there. So here it is given. In amplitude modulation, the message signal. Okay, so message signal is given by 10 sine 2 pi into 10 raised to 5 t volts. So this is omega. This whole term is omega. And carrier signal. So carrier signal is given as 20 sine 2 pi 10 to the power 7 t volt. If we compare, we get, so V maximum, so Vm max peak, so the amplitude is 10, here it is 20, whereas these terms are your omega, angular frequency. Now we know bandwidth, so bandwidth is twice of frequency modulation 2fm, and m is your message signal, frequency of message signal. So frequency of message signal, okay, and omega m is angular frequency of message signal, angular frequency of message signal. So that therefore that our bandwidth of the modulated signal is, so we have to find frequency of message signal. First we have to find that. So that will be omega m upon 2 pi. So omega m is how much? 2 pi into 10 raised to 5 upon 2 pi. 2 pi gets cancelled. The frequency of message signal is 10 raised to 5 hertz. So bandwidth will be twice the frequency of message signal. So 2 into 10 raised to 5 hertz, or we can write it as 200 kilohertz. So I hope you have understood, students. Okay, students, so we'll move ahead with the next question. So in the next question is given a carrier signal. C is given as 25 sine 2.512 into 10 raised to 10 t is amplitude modulated by a message signal. So message signal is given phi sine 1.57 into 10 raised to 8 t and transmitted through an antenna. What will be the bandwidth of the modulated signal? Okay, so the bandwidth of the modulated signal is twice frequency of message signal. So first you have to find the frequency of message signal. So your message signal is given by phi sine 1.57 into 10 raised to 8, sorry, 10 raised to power 8 t. So from here we have angular frequency of message signal is 1.57 into 10 raised to power 8, that radians inverse. So that is your radian second inverse, sorry, radians per second. So that is our angular frequency. So your frequency of message signal is angular frequency upon 2 pi. So 2 pi is 2 into 3.14. So this is 1.57 into 10 raised to power 8. So this is 1 za, this is 2 za, 2 2 za, 4 by 1 is 0.25 into 10 raised to 8 or 25 into 10 raised to 6 hertz. This is the frequency of the message signal. So my bandwidth is twice of frequency of message signal. So 2 into 25 into 10 raised to power 6. So that will be 50 10 raised to power 6 hertz, or it will be 50 megahertz. So 50 megahertz, correct option is D. I hope students you have understood this question. Okay students, so moving ahead with the next question. A signal A cos omega t is transmitted. So AM is given as A cos omega t is transmitted using V naught sine omega naught t. So carrier wave AC converted to V naught sine omega naught t. This will be VC. The correct amplitude modulated wave is. So when amplitude modulation takes place, so amplitude modulated wave is given by amplitude modulated wave is y equals A naught plus AM sine omega naught t, where A naught is amplitude of the carrier wave. A naught is amplitude of carrier wave. So substitute, so Ym will be equal to A naught. A naught carrier wave is V naught plus AM is A cos omega t into sine omega naught t. So if you open the bracket, we get V naught sine omega naught t plus A cos omega t sine omega naught t. So if you multiply by 2, divide by 2 and multiply by 2 over here, so you can write divide by 2 and multiply by 2. So this term will become 2 sine A cos B. This will become V naught sine omega naught t plus A by 2. So 2 sine A cos B sine A plus B by 2, sine A plus B. So sine omega naught minus omega t plus sine A plus B, omega naught plus omega into t. So this is your amplitude wave. So that will be your correct option, will be D. I hope you understood, students. Okay, students, in the next numerical we have, in an amplitude modulator circuit, the carrier wave is given by, okay, so carrier wave is given by 4 sine 20,000 pi t, and modulating signal is given by 2 sine 2000 pi t. The value of modulation index and frequency of lower sideband will be how much? Now from carrier signal, amplitude and amplitude and frequency carrier of carrier wave is. So we compare, so amplitude is 4. We have omega as to 20,000 pi. So your frequency of carrier will be omega upon 2 pi. So that is 20,000 pi upon 2 pi. Pi gets cancelled. 2 ones are 2,000. So that is 2 kilohertz. Similarly, amplitude and frequency of modulated wave. So amplitude of modulated wave directly we can see here is 2, and here the omega of modulated wave is 2000 pi. So frequency of modulated will be omega m upon 2 pi. So that is 2000 pi upon 2 pi. So the value will be, students, here there is a mistake. So 20,000, that will become 10,000. So that will be 10 kilohertz. Sorry, and here it will be 2 ones are 2, 1,000 are pi gets cancelled. So 1 kilohertz. So the modulation index is AM upon AC. So that is 2 by 4. So that is 0.5. Modulation index 0.5, and frequency of lower sideband is FC minus FM. So that is 10 minus 1, that is 9 kilohertz. So 0.5 and 9. The correct option is D. So I hope you have understood, students. Okay, students, so moving ahead with the next question. A 100-volt carrier wave is made to vary between 160 volt and 40 volt by a modulating signal. What is the modulation index is? So modulation index is A max minus A minimum upon A max plus A minimum. That can also be written as V max minus V minimum upon V max plus V minimum. So V max is 160 minus 40 upon 160 plus 40. So that is 120 upon 200. So that is 1 decimal. That is 0.6. So correct option is C. I hope, students, you have understood. Moving ahead with the next question, students. So we have given a signal of 5 kilohertz frequency. So FM is 5 kilohertz. Is amplitude modulated on a carrier wave frequency of 2 megahertz, and ये हो गया 2000 kilohertz. The resultant frequencies of the resultant signals are, so the frequencies of resultant signals will be frequency of lower sideband, frequency and frequency of upper sideband. So frequency of lower sideband is Fc minus Fm. So Fc is 2000 minus 5, so 1995 kilohertz. F is already 2000 kilohertz, and F's upper band sideband will be Fc plus Fm, that will be 2000 plus 5, so that is 2005 kilohertz. So your correct option will be C. I hope students you have understood. Okay students, in the next question what is given? An amplitude modulated signal is plotted below. Okay, so this is amplitude modulation. Which one of the following best describes the above signal? Okay. Now for an amplitude modulated wave, the equation is given by equation of amplitude modulated wave. So that is given by AC plus AM sin omega t omega mt sin omega c t. Now from figure we will see we have maximum amplitude AC plus AM is 10. This is maximum amplitude, and AC minus AM equals 8, that is minimum amplitude. So from here we'll get right AC is 9 and AM is 1. So we got AC and AM. We'll solve. Now for angular frequency, angular frequency for carrier, angular frequency for carrier wave. So omega c is 2 pi. F is not given but time period is given. As you can see, for carrier the time period is 100 micro. Carrier is the highest frequency, right? So it is 8 microseconds. So 2 pi, and that is 8 into 10 raised to minus 6. So that is 2.5 into 10 raised to pi to 10 raised to 6 10, so 10 raised to 5 radians per second. And for message signal it is 2 pi by angular frequency for message signal TM, that will be 2 pi, and for message signal as you can see it is 100 into 10 raised to minus 6, so it will be 2 pi to 10 raised to 4 radians per second. So my final equation can be written as, so we have AC as 9 plus AM sin omega mt. So we have AM as 1, so 1 as it is, sin omega m we got as 2 pi into 10 raised to 4, 2 pi 10 to the power 4 to the bracket, again sin omega c is 2.5 into 10 to the power 5 t. So 9 plus, okay, 9 plus sine 2 pi 10 to the power 4. So correct option is B. So I hope you have understood this question, students. Okay, students, so we'll now move ahead with the next question. Okay, so in this question what we have is the modulation frequency of an AM radio station is 250 kilohertz. So FM modulating frequency is 250 kilohertz. Frequency is 250 kilohertz, which is 10% of the carrier wave. So my carrier wave will be, so FM is 10% of FC. FC will be 100 by 10 of FM. That is 100. That is 10 times of FM. So that is 2500 kilohertz. So that is FC. Now what is given for a given carrier wave? If another AM approaches you for license, which broadcast frequency will you allow? So for a given carrier wave, for a given carrier wave, FC with modulation frequency FM, the bandwidth is calculated by, so bandwidth is, so upper bandwidth will be FC plus FM and lower bandwidth will be FC minus FM. And to avoid overlapping, we can take frequency as FC plus or minus 2 FM. So we can make it twice. So F1 will be FC plus FM. F1 dash will be FC minus FM. So F1 will be FC is how much? 2500, sorry, plus 2 FM minus 2 FM plus 2 into 250. So that will be 3000 kilohertz, and F1 dash will be FC minus 2 FM. So that is 2500 minus 2 into 250. That will be 2500 minus 500. That is 2000 kilohertz. So the correct option will be A. Okay, students, we'll move ahead with the next question. An amplitude modulated wave is represented by, so amplitude modulated wave is given by 10 into 1 plus 0.2 cos 12560 t sine 111 into 10 raised to 4 t, right? So if the modulating frequency will be, so the modulating frequency have to find. So if we compare with, comparing with CM as AC plus AM sine omega t to sine omega c t. So we have omega m as 12560 radians per second. So frequency of modulated is omega upon 2 pi. So that is 12560 into, sorry, upon 2 into pi can be taken as 22 by 7, so 22 into 7 numerate. So if you'll solve this, 2 ones are 2, 6 are 12, 2 so 4, 2 8s are 0 are. So if you'll solve, this will be coming as 2000 hertz, or you can also write it as 2 kilohertz. So correct option will be 2 kilohertz. So approximate answer is 2000 hertz, students. So that's your correct option. But if you'll go on solving, actual answer will be 2170 hertz or 2.17 kilohertz. I hope you have understood, students. Moving ahead with the next question, students. Which of the following four alternatives is not correct? We need modulation to increase selectivity. Yes, we need modulation to increase the selectivity, because in modulation then the frequency changes. To reduce the time lag between transmission and reception of the formation signal, no, it does not reduce, it does not reduce the time lag. To reduce the size of antenna, that is correct. Yes, you can write it as wrong. And to reduce the fractional bandwidth, that is the ratio of signal bandwidth to the center frequency, yeah, that is also correct. So out of this, the wrong answer is section B. So I hope you have understood, students, the numerical based on communication. Thank you.